Good afternoon everyone. Today we will discuss about mechanics and hydromechanics, and this presentation aims to understand the definition and function of mechanics and hydromechanics. Mechanics is a branch of physics that deals with the study of motion, forces, and energy. It plays a crucial role in understanding and describing the physical world around us. It is based on Sir Isaac Newton's law of motion, which describe how objects move in response to forces. Mechanics has many practical applications in various fields, such as engineering, physics, and everyday life. Mechanics as a branch of physics is essential in understanding and describing the physical world around us because it deals with the study of motion, forces, and energy. It is based on Sir Isaac Newton's law of motion. Number 1. Kinematics is the branch of physics that describes the motion of objects without considering the forces involved. Kinematics is a branch of mechanics that deals with the description of motion without considering the forces that cause it. It focuses on analyzing the position, velocity, and acceleration of objects as they move. Kinematics is important in understanding how objects move and how their motion changes over time. Number 2. Dynamics. Dynamics focuses on the forces causing motion. Newton's law of motion are fundamental principles in dynamics. Dynamics, on the other hand, is a branch of mechanics that focuses on the forces causing motion. It is concerned with understanding how forces act on objects and how they affect their motion. Newton's law of motion are fundamental principles in dynamics that describe how forces affect the motion of objects. Number 3. Energy. Mechanical energy is the ability of a system to do work. It is divided into kinetic energy associated with motion and potential energy associated with position. Energy is another important concept in mechanics. Mechanical energy is the ability of a system to do work. It is divided into two types: kinetic energy and potential energy. Kinetic energy is associated with motion, while potential energy is associated with position. Understanding energy is crucial in understanding how objects move and how much work can be done by.
4. Statics. Statics deals with objects in equilibrium where there is no net force acting on them. It involves the study of force acting on stationary objects. Concepts such as torque and moment are crucial in statics. 5. Fluid mechanics. Fluid mechanics studies the behavior of fluids, liquid and gases, and is divided into fluid statics and fluid dynamics. Fluid statics deals with fluid at rest, while fluid dynamics considers fluids in motion. Application range from understanding blood flow in the human body to designing aircraft. 6. Circular motion. Circular motion involves objects moving in a circular path. Centripetal force is necessary to keep an object in circular motion, and it is always directed toward the center of the circle. Conclusion. Mechanics is a fundamental aspect of physics providing the foundation of understanding the motion and behavior of objects in the universe. Its principles are essential in various scientific and engineering disciplines, contributing advancement in technology and our comprehension of the physical world.
Hydromechanics, also known as fluid mechanics, is the branch of physics that studies the behavior of fluids, liquid and gases, and the forces acting on them. It involves the principle governing fluid flow, pressure, and related phenomena. Hydromechanics is a vital field that has numerous practical applications across various industries and disciplines. Its principles help us understand the behavior of fluids in motion and design efficient systems for managing fluid resources while minimizing environmental impacts. Fluid dynamics Hydromechanics is based on fluid dynamics, which is the study of fluid in motion. It applies this knowledge to analyze the behavior of fluids in different situations, such as in pipes, tank, or open channels. Fluid forces. Hydromechanics studies the effect of various types of fluid forces such as pressure, drag, lift, and viscosity on objects immersed in fluids. It helps us understand how these forces affect the behavior of objects in different fluid environments. Fluid mechanics. Hydromechanics also deals with concepts such as fluid mechanics, which help us understand how fluid flow and behave in different situations. This knowledge is essential for designing efficient system for transporting fluid or managing fluid resources.
Hydraulic engineering. Hydromechanics has many practical applications in hydraulic engineering, such as design water supply system or managing plants and coastal erosion. It's self-engineering design structure that can withstand fluid forces and manage fluid resource efficiently. Marine engineering. Hydromechanics is also important for marine engineering application, such as design ship or submarine that can operate efficiently in marine environments while managing fluid force, such as waves and currents. Conclusion. Hydromechanics is a vital field that has numerous practical applications across various industries and disciplines. Its principle helps understand the behavior of fluids in motion and design efficient system for managing fluid resource while minimizing environmental impacts. Thank you for listening.